Recorded, yeah, 75 slides. All right, so all we're going to do is just point 3, okay? So hopefully get you to the point where you can do these. As you see, as I mentioned, this is exactly like the one the student asked me. It's probably the same problem, just with different numbers. So I'm going to kind of go quickly, bam, bam, step 1, step 2. Slow me down, holler if there's something you don't understand what I did, okay? And remember, you don't have to write these are on the slides. So this is how a question would be, oh, we got the laser still. This is how a question would be given to you, is you're given a function, you're given a point of interest and an epsilon. As I mentioned, last class, you may not always be given the limit, so you have to find it. The very first thing I'm going to do is find the limit by plugging in my x0 value, which is what hopefully you did Monday, and I think your quizzes, the grades are already. I'll hopefully find those sometime today. And so all I've done here is where I see the x is I've plugged in the -6. Okay, so multiply all that out. Negative times negative is positive. Square root of 25 is 5. So that becomes my L, my limit. So now I have, and I just plug everything into this. Again, this is repetition, just over and over doing the same thing. If you're struggling with this, well, one, if you're struggling right now with it, maybe you haven't worked any problems, okay? But you want to start working through a lot of these. So what I do, I do the plus and minus. Now I just isolate my x. So the 5 to all 3 pieces. And then I'm just repeating this so you see it again. I would square all 3 pieces. So what you just wrote down, and then I would, from all 3 pieces, this one, as you can see, I'm going to flip the signs because you're going to divide by a negative. So there's my divide by -4 divided by -4, and notice I flip the signs. Along the way, and I'm guessing that this only had 4 decimal places, but especially you guys have the TI calculators, keep all your decimal places till the very end, okay, until it tells you what to round to. And so again, from this step, it flipped around because that kind of makes more sense to me. That's smaller, that's larger. And so I'm done with step 1. Okay, again, what I would do is I would look at this x0, is it in that interval? This is kind of like plugging values in when you took algebra to see if it was correct. Look and make sure it's in this interval, because I wouldn't go to the trouble to go to step 2 if it's not. That means you did something wrong up here. Okay, so it's in the interval, and so I can even look at it, and now, and again, it depends on when you center it. Again, a lot of you probably can just look at this one if you actually graph it, okay, to get this distance here. You don't have to go through those step 2, but let's do it. I mean, because certainly you can see that's the smaller. So this is all you're doing in this step, is you're centering it, which we could just see visually. So let's go through the steps and do it. Again, this is our, subtract 6 from all pieces, set this piece equal to the lower interval, set this equal to solve, and as you can see, this was the smaller piece. Okay, if you graph it, like I keep telling you to graph, you don't even have to write all this junk, because you can just see from the actual graph, and again, that helps you to know what you're. And so this is hopefully why it makes sense you're picking the smaller value. All right, so that was the end of the notes. We just didn't get to, and maybe if I would have gotten to it, the student would have been okay with that problem. Also, with this precise definition of a limit, is you can actually prove limits. So the example is, it says prove the limit using the limit definition. So if I plug in 0 here, you can see that, yeah, the limit equals -4. But let's actually go use the precise definition and actually prove this. So the first thing we need to do is get all of these pieces here. So what's x0? What's L? 4, and f of x is your function. Yeah. So I mean, you have to figure out what all those pieces are. Remember, this is always x is heading to x0, my value of interest. Now that I have here, well, I just simply find my interval. So I plug in my function, 3x minus 4, minus my limit, negative 4. I don't have an epsilon value. When you do a proof, you're proving for any epsilon. That's what a proof is. It says you want a 0.01 error, you want a 0.05 error, doesn't matter. Okay, so I'm going to end up actually with something I can just plug in. So I go through the steps, negative, negative, positive, so that goes away. Everything by 3. And so what this is saying, I don't care what error you pick, what epsilon you pick, I can always tell you this will always work for any value if you just take it and divide it. All basically you have to do. Well, we can say, well, let's go ahead and center this. I plug in my 0. So again, I have my minus delta, I set to the lower end, my positive delta, and as you will see, I'm going to get the same value. Okay, so in other words, it does not matter what value you pick here, okay, for your error, for epsilon, you will always get, this will always be true, okay, and you will always be able to, it will always be centered. All right, so this is just, you're doing the same exact steps, but just going through a formal proof. And so therefore, any given epsilon, any epsilon given, delta can be found simply by dividing by 3. All right, example 3, are we okay? No, I'm going very quickly, so again, let me know if I'm going too fast. Prove the limit using the limit definition. This is an exact homework one, and it's horrible, is why I show this one. Step 1, I go through all my steps. This, I mean, it's kind of weird looking the way this is written out. That is my function. That is my limit. And then, of course, that's my x naught, which I don't even use in this step. So as you can see here, my f of x minus my limit. Okay, I kind of am getting now where I'll skip writing this step. So I do my negative and positive. And so I go through the steps. I think a lot of the reason this is horrible is even at this level, y'all still don't like fractions. And so I just add 2/9 to each piece. And hopefully you kind of remember this, where if this is on the bottom, you can just flip it, but we're taking reciprocals, meaning 1 over this, 1 over this, 1 over this. So that's what all this mess is. When you flip this, you have to flip the signs as well. Okay, and if you ever get where you forgot to flip the signs, it's not going to matter, because at the end you're going to say, wait, that number's smaller than that number, so I apparently forgot to flip somewhere. Okay, again, if you logically look at this. So I've flipped the signs here. Okay, now I have this big mess. Oh, I did one more step here. I multiplied everything by 2. Okay, so that's where the 2's came from. So now I have my related. I'm just writing this. But now I'm going to flip it around. Okay, as I said earlier, we kind of like it flipped around. And this is the part here that you say, woo, I'm done. My math lab says, no, you're not. They want you to make it look prettier. So what you have to do is here, you have to find a least common denominator. Well, there's only one denominator, 9. So as you guys typically say, you're cross multiplying. Okay, so in other words, I'm making this over 9. So 9 epsilon over 9. So I have one fraction here. Again, hopefully you kind of remember with fractions, if you have a fraction in the denominator, this denominator actually goes up to the numerator. So 9 times 2 is 18. So that's where I'm getting these. As you can see, they're very similar. And this is my actual interval. Well, again, this would be nice and happy if we didn't have oh, great, you know. Now I have to actually simplify. So this is, I plug in my value, my x naught. Remember, this was given. And here, which is actually kind of nice because it was just a -9, I add it to all pieces, and I set this equal to the lower. I set this equal to the, okay, so from step 1, this is going to equal that. This is going to equal that. So in all these steps here, basically all I've done is, I could say I put this on this side and then I subtracted my fraction. Again, my math lab, well, I'll tell you how I did this. You probably could stop at this step, because I'm going to tell you here at the end, I just picked small values of epsilon to see which one's smaller. So it really didn't matter if you went through these steps, but if I go through the steps, what I did is I had a common denominator, so 9 times that denominator, and which is kind of nice because the 9 times 2 is 18, the 18s cancel, you end up with that. Do the same thing up here. In other words, I end up moving and in this case, I guess I moved this back over here. So I solved the same thing, and it's by looking at these two, it's the smaller value. And some of you right away might say, well, this with the negative is going to be the smaller value. Remember what epsilon is. Epsilon is my error. So in a perfect world, I want it to be 0, but it's never going to be 0. So what I picked really, really, really small values, okay, and you're going to see what happens here is you're going to end up with a negative over a negative. It's going to give you a positive. And so this actually is the smaller value. So where I saw epsilon, I plugged in this very, very small value and found the lower equal to this, the upper equal to this. Don't let the negative throw you because we're talking distance, so that's going to be absolute value. And as I can see, this value is actually smaller. Okay, I'm almost positive, I don't know if any of y'all have worked or tried this yet, I'm thinking this is a multiple choice where you go kind of through steps of it, okay? And so what I would do is I would go back through all these steps. Again, it's just ugly, but it's algebra. I mean, all this ugly stuff is fractions. That ain't even algebra. It's just basic math. But so you at least understand, I wouldn't put something this difficult on a test. I think this is probably the hardest problem in the homework. All right, so this is the last application in the homework. And I did another one, and I did end up putting in Blackboard the grinding of the cylinders. Okay, so hopefully you saw that. That's a homework question. This is a homework question. So it says Ohm's law for electrical circuits like the one shown below states that V, my voltage, equals R, my resistance in ohms, times my current. Okay, so I have this equation here. Your firm has been asked to supply the resistors for a circuit in which this voltage will be 120 volts and I is to be 5 plus or minus 0.1 amp. In what interval does R have to lie for I, in this case my current, to be within 0.1 of this value? Now, again, you're in the math world, so it was kind of nice of them to do this so you kind of have an idea what your x sub 0. All right, so we have all this information given to me, and we say, well, in my f of x minus L, I always have a function. Hey, there's a function. But the problem is here is I'm interested in this I value, and it says right here, in what interval does R have to be in? So that's my x, that's what I'm centering around. So what I'm going to do is I'm going to solve this for I, okay, this equation, but then I'm going to use this as my function, and I'm going to center it around R. That's my actual. All right, so here's all the pieces again. So I'm doing the same thing, my f of x minus my limit less than epsilon. I went ahead and put in my V will be 120 here. So I plug this in here, my 120 divided by R. It tells me here my limit. I want to stay within this plus, well, I want it to be 5, but then my error, I want it to be plus or minus 0.1. So that's my, and that to me was probably the hardest part of the problem. Now we go along our merrily way and we do our algebra. I will have word problems like this on your test. I know you have a test coming up. And so, like I always tell students how to study, certainly work anything we've worked in class and work your My Math Lab, go back through the study plan, working problems like this. It's kind of unfortunate that fortunate for you, you're in a 50-minute class, so I can only give you a 50-minute test, which I told my Tuesday, Thursday class, that's all they would get either. I'll just do something else or I'll let them go after 50 minutes, I guess. All right, so we go through all, meaning let's add to every single piece. And so now, as you can see this, hopefully you're starting to see, well, we're just doing the same thing over and over and over. This is like the one that had the x in the denominator. I'm going to flip everything. I'm going to flip the signs. And so now I just move things around, okay? In other words, to put the smaller one on the left. Finally, I multiply everything by 120, and I get my actual interval, okay? So it gives me my true interval, and what I would do, and this problem didn't say anything about graphing it, it just said it wanted the interval. I would graph this, meaning I would graph my function, I would put my line, and that's why I showed that graphing program. I wasn't sure that this isn't the same thing if it would do things like x equals, and it does. So I graph it, and then the next thing I do, these dotted lines, probably, I would have zoomed in more, but then you couldn't have seen this is 5 over here. This is my 5.1, I'm a little bit above it, and this is my 4.9, I'm a little bit below it. And so x values in here, so, or r values. And so in other words, this is showing me that I have to stay within this interval. Another reason this is a perfect example, because they didn't tell me, they just said pick up, an interval for r. So you might wonder, well, how do I know if this is correct? If you didn't touch that, if your function's not there, say you graph this and your function's over here somewhere, then you did something wrong, because what you're trying to do is hit that true value, that limit value, and you're saying, well, I can't hit it, but I can stay within this interval, and it keeps me within my plus or minus epsilon, my error, okay? So I actually get my output error.